Let's have a look of this command set at a closer look and understand what we will do. So here we are assigning sequence of consecutive index number to data frame rows using nrow function. Have a look of the program line by line. The first is data new1, which is equated to data. So what we are doing over here, we are duplicating the data. Our original data frame was having a variable named data. So we have duplicated the data over here. Next, we assign sequence to row names. We are assigning a sequence number, which means the row name will be having serial number from 1, 2, 3, 4 and so on. So what we do? We use row names and within brackets we pass data new1. So data new1 is our duplicate data. We can see over here that data new1 is our duplicate data. On that data, we are assigning row numbers from 1 to nrow data new1. An nrow function is used to give sequence of consecutive index numbers. So we have assigned from 1 till the number of rows, and then we write data underscore new1, which is printing the desired table on the screen. So you can see over here that table 2 is printed on the screen and the row names are 1, 2, 3, 4 and 5. So you can see that we have the 5 rows, and in the 5 rows we have 3 columns x1, x2, x3 that we generated with the help of our data frame. So students, replacing missing data depends from company to company and on their policies, that how they replace the missing data. Every company has rigid rules and they work according to their rules. Factual analysis can be defined as an estimating the probability of a suspect's guilt or innocence based on investigative findings. So basically, when we say factual analysis, it means that what are the facts that we have, and then having those facts in our hand, we do the analysis and then we estimate the probability of the suspect's guilt, that how much that particular suspect is guilty or innocent. Each investigator uses factual analysis to narrow the scope of suspects. So we go for the factual analysis and try to analyze the data, and then we narrow the scope of the suspects and to eliminate innocent suspects and to focus the investigation around a particular suspect most likely to be guilty. So factor analysis in R is a statistical technique that simplifies the data interpretation by reducing the initial variables into smaller and smaller factors. So basically, factor analysis in R is a technique which simplifies the data by reducing the variables. So students, factor analysis is also known as exploratory factor analysis in a statistical technique. It is exploratory factor analysis because here we are trying to explore something and we are trying to go into the depth of a particular factor and understand that why this has happened. It identifies the inactive relation structure and further narrow down a pool of variables to a few variables. So when we are doing factor analysis, we are trying to find out the inactive relational structure, the relations which are inactive, and further we focus only on the pool of variables which are of some purpose, and we go to very little variables and only on those variables we work and then find out some kind of analysis on the data. We find out which factor is most responsible for influence in the categorization of the weights. So that is how we have to understand which factor is playing an important role and which factor is more influential, and then accordingly we have to analyze the data. Students, there is a very powerful function called as factornal, and this factornal function has two variables as a parameter. The first one is x, which is definitely the data set, and the second one is factors, which are the factors or specified number of factors to be fitted. So factornal is a function which is basically working on a data set and along with the factors which are passed as parameter for factor analysis. Let's take one example and understand what it is. Let us suppose there are a number of food available in the data set with their food texture, data points such as oil, density, crispy, fracture and hardness. So mainly we are saying that there is a data set of food and their food texture data points are divided into 6 categories. We can say 5 categories. We can say oil, density, crispy, fracture, and hard. Here we are reading a CSV file of food textures. You can see over here that we are reading the CSV file and storing that in food textures, and that CSV file is procured from internet. We can see https user page dot fiberlin.d.soga. something something till food texture.csv. So basically I'm fetching a file online, and in the food textures we get a subset of food textures where all the rows are selected and only the columns from 2 to 6 are selected. 2, 3, 4, 5, 6. Basically the 5 columns are selected. When we go for factor analysis, we call the fractional function, and in that we pass the CSV file which is there in the food textures, and we pass factors equals to 2. So we have taken 2 factors and then we print the factor analysis. That is how we are printing the factor analysis. So now we will see that output to be presented as a PNG file, and how we print the output. We call the PNG function and we pass the file equals to factor analysis gfg.png. So we are producing the result of the factor analysis, which is coming with the help of the fractional function. We get the result in the PNG file. We plot factor 1 by factor 2. So the 2 factors are plotted, and we use the load variable where factor analysis and loading, we are loading the columns, all the rows and the columns from 1 to 2. And then we plot the graph with the help of plot function, where we load and we pass the type equals to n, and then we give the text function and load label equals to name food texture cx is equal to 0.09. This is the value, and then dev.off where we are saving the file. We call it device off. So now let's have a look of the output and understand how this result comes. And we see we have called the factorial where x is equal to food textures and factor is equal to 2. So you can see first factor and second factor, and then uniqueness is coming oil, density, crispy, fracture, hardness, that you can see the output. Loading of factor 1 and factor 2, so you can see the output over there, and for factor 1, factor 2, you will see the SS loading, proportion variable, and up till the chi-square value and the p-value. And you can see on the graph factor 1 and factor 2, you can see where the values are located, where is crispy, where is hardness, where is fracture, and so on. So that is how we can do factor analysis very easily with the help of a fractional function. Median imputation method. Now, after understanding factor analysis, there is something called as median imputation method, which is also very simple. What median means? We all know that if we arrange the data from the lowest to the highest value, the middle value is called as the median. It is the mid value of an arranged value. So suppose there are 10 numbers ranging from 1 to 10. So in that case, the median would be 5.5 because it is the average of 5 and 6. So basically, this method is suitable for numeric variables. Therefore, these methods are suitable for continuous and discrete numerical variables only, because there we are trying to find out the median or the mean value and putting these value into the blank records. So this method will basically replace all occurrences of missing value with a variable with the mean or a median of that variable. So basically how we go about it, it is very simple. Suppose I have a data set where 80% of data is there, but 20% of data is not available for a particular column. So what will I do? I will find out the median or mean of the existing data. If the data is having a normal distribution or the data is similar, in that case, I can say that I will find out the mean or median of that particular 80% data set. And finding out that mean and median, I will replace all the any missing values with that mean or median. For example, I am appearing in an examination and I have 8 subjects and I have appeared in 6 subjects. So in all the 6 subjects, I have scored marks and the average of those marks is, let's say, 65. So what I will do, for the 2 subjects in which I was absent, I will be awarded 65. So 65 is what? That is the mean marks of rest of the 6 subjects. So here, considering my performance in the 6 marks in the 6 subjects, the average marks is calculated and that is stored in the not available values cells. So this is basically the policy of a college or a university to award marks to a student who is not able to appear in a particular subject due to any of the reasons. Sometimes the median imputation method has exact median value. Sometimes they have a mean value, and sometimes they consider just a passing value, or we can say a minimum value is given on that cell so that the loss is not done. For example, for a student, if the university says that we will not give them the mean or median, we will just give them the pass percentage, maybe 50 marks. So in that case, they will give only 50 marks over there, and it is their policy to award 50 marks to any of the student who is not able to attend the examination or appear in the examination. So this is called as median imputation method because I'm imputing that particular blank cell with a particular value, which is an assumed value. It is a value which is not the real one, but it is assumed on the basis of some value which is present for that particular column. There are certain assumptions that we have to understand. For median imputation method, data is missing completely at random. So first thing is, we assume that data is randomly missing. It is randomly missing at locations. Second thing that we have to assume is that the missing observations most likely look like the majority observations in the variables. So we assume that the rest of the data is like, and the missing values are also the same. So like a student scores somewhere around 60 to 70%. So we can always say that the person has an average marks of 60 to 70. So we can definitely give them 65 if he is not able to appear in a particular exam. So if the values are similar, in that case, we can go for a median imputation method. If data is missing completely at random, then it is fair to assume that the missing values are most likely very close to the value of the mean or the median of the distribution, as these represents the most frequent average observations. So we always say that it is fair to find out the mean or the median of the distribution and replace mean and median with the missing value, because if the data is the distribution is like, or we can say the distribution is normal, or the mean and the median and mode all are same. If mean, median, mode is same, it means it is a normal distribution. And if the data is normally distributed, it means all the data is same. So in that case, if certain data is missing, we can definitely assume the mean or the median, and we can replace the not available values with the mean, median values. There are certain advantages of median imputation method. It is very easy to implement because already some data is existing, and from that data we are procuring the values for the not available data. Fast way of obtaining complete data set. Definitely it is very fast way of completing a data set because some data, 80% of the data is existing for that column. So very easily we can apply certain functions on that data and we can procure the data for the not available. Can be integrated into production during model deployment. Definitely we can integrate median imputation method in the production during model deployment, because if sometimes data is missing, automatically certain programs can be executed and the data can be furnished with the help of computation of mean or median. There are certain limitations to this method. Distortion of the original variable distribution. Because sometimes certain outliers can be present in the not available data, and those outliers are ignored because we are just assuming that the data has to be equal to mean or median. So distortion of the original variable might take place, and distortion accordingly of the original variance can also take place, because if at the not available data there were some outliers or exceptional cases, we are not considering them because we are considering the median values. So in this case, if the original data was a very high data or very low data, in that case there will be a hell lot of distortion of the original variance and original variable distribution.